Okay, now we're going to dig into the Orsus and find out what it's going to do. And I guess we're going to start with some cutting this morning. Is that right?
We are. So here I have Aaron Angelacos, one of our laser application engineers, who's going to work this portion of the presentation. So this happens to be the 8 kilowatt version of the Orsus. We have some 18 gauge and a mild steel. This will be processed around 2,000 inches a minute.
Wow.
Quarter inch. About 350-ish on feed rate for that. And then we're going to go into some 3/4 inch mild steel around 30 inches a minute. Okay. With that said, I'll turn it over to Aaron and we can get the machine processing some materials for you.
All right, good. Thank you, Aaron, for being with us today.
No problem. Thanks for having me.
Yeah. So tell us what's about to happen.
So right now I start with loading in my program from the main screen of the control. So I'm going to select my NC that I want. I'm going to go into my edit screen. From the edit screen here, we're going to utilize our i-Cas, which is that internal camera that Matt had mentioned.
Oh, right.
So I'm going to select the i-Cas function down here.
That's in the ceiling of the enclosure, right?
Correct, yep.
Okay. Mm-hmm.
So it's actually taking a still picture of what we currently have on the bed. So that can be larger sheets, are mostly used for remnant materials like you see here. So here you can kind of see if I zoom in, we have the part laid out there. If I select parts layout, it'll highlight it in red. From here I can actually drag this to wherever my material that I want to cut is at. So for this particular one, for our 18 gauge, it's going to be on this smaller sheet here. So I'm just going to kind of move it to where I think is a good fit. You know, I do have some material to play with. Once I have it set, I'm going to hit apply. Now that's going to lock my position in from the home location where the gantry sits. From here I can go to process. And in this instance, we're only doing one singular part. So it's created my data that I needed for my location here in the NC code. Now we can basically hit the start button and it's going to start cutting for us.
Okay, good. Quick question for you there.
Yep.
If you had a hot job come in, could you manually make like a mini nest on something?
Yeah, so I can show you that as well.
Okay.
So if we go back to our program edit screen, if we knew, let's say we know what the sheet size is. So let's say it's 48 by 48. Now it'll give us a highlighted square here.
Okay.
So let's say if I go to my multiple part selection, here I can tell it, okay, maybe I want to do a piece count. And based on where my home position is right now, it's going to say I can fit 4. If I change my home position to, let's say, 0 and 0, now I hit piece count. Because we know the sheet size based on our part size and spacing, we can nest out what we call kind of like a second shift nesting, right? It's a base logic to allow us to add one or more parts into a sheet.
Okay, so it not only will let you do it manually, it'll do it automatically.
Yep.
For you.
Yep.
Beautiful. Okay. Thank you.
Yep. So if we're ready to cut now with the single part, we have everything ready. Our NC is ready. I can hit the start button and it's going to go into cutting for us.
Okay.
So we have the particular nozzle already installed in the head, so it doesn't need to do the nozzle changing function for this one. But when we switch to our other materials for you to see, we'll be able to see a couple of those LNS features in action.
Oh, good. Yeah.
Here we're doing some standard flash cutting. I'm sure some of you are familiar with that feature. We're kind of doing a series of interpolations for the rounds as opposed to doing one at a time. And then the same with the squares. We're kind of doing fly cutting in both X and Y directions.
Yeah, you can see the horizontal and vertical where you're turning it on and off.
Yep.
Yeah. Wonderful. All right. Oh, and you're able to keep a live track of what was happening there?
Yep. So the NC is basically a one-to-one to what's happening inside the laser.
Okay.
And you can see as we traverse across the material, it starts to turn green on the areas that were already completed.
Okay.
This is very nice for another feature in our operations tab. where if we wanted to reprocess the sheet, those finished sections, we can actually select a specific area and restart the program for if there was any type of failure or miscut or something.
Yeah.
Maybe the operator put in some wrong info in the cut condition and we lost the cut. We can basically start from the next operation by selecting a specific area.
Knowing that that's already done, the laser
Correct.
will go
Yep.
to the next step.
Yep.
Right. Okay. Gotcha.
Another nice feature about the operations tab is part select. On the 4i control, it allows us to break down nest into specific part names. So if you have a nest that has multiple parts inside the nest,
Okay.
it'll show up here with the part name. So if I were, let's say this was a multiple part, if I selected P1, it would pull P1 out and I can
Yeah.
make a single NC of P1 and then I can grid it out or make
Okay.
one or multiple of that single part.
Can you mix on a remnant like that or no?
So when you do it from here, it
Yeah.
only allows you to select more than one.
Yeah.
Select one. If you wanted to do more than one, you would make each individual one.
Oh, I see,
Bring it
yeah.
out of the nest, and then do that i-Cas feature that I showed, where we select one on a remnant.
Right.
And we can add more than one part there.
Ah, okay.
Yes.
So it'll say, hey, this part's already taken, so to speak. Now you can make the grid that's everything except that taken spot.
Correct.
Yeah,
Yep.
got it. Okay, wow, handy.
So it's very user friendly. Very easy for break-ins. Hey, we got a hot job. We need you to do this real quick, and
Yeah.
we can stop what we're currently doing, and then we can also get into something different very quickly.
But hot jobs never happen, right?
Right, exactly. Hot jobs never happen. So in this case, that program is finished. We can go into cutting our next material. So again, we'll go back to the load screen here. I'll go into my program edit. If I zoom in, you can see we have 4 parts. Now I already have a predetermined location for this material. So I'm just going to go ahead and verify that my laser condition is good, everything was applied. One thing I like to note is our M102 line is calling up that information, right? So that's the material type, our nozzle that we're using, and then all the cutting data that is required to produce these parts. So knowing that that's there, it also gives us a white indicator here saying that everything is good to go. We're in the green, we're ready to cut the material.
How does it know all that
So
information?
this M102 line is
Yeah.
part of the G and M codes that are spit out through
Oh,
our
okay.
software.
Yeah.
So when you create a program offline and you bring it to the machine, our software has those parameters that you're allowed to select for the specific material type and thickness.
And that'll pop up on a screen. You can select the part name.
Correct. Yep.
Beautiful.
So that you use that as you're traversing through our NC creation in our virtual environment in our software. And then when you bring it out to the machine, you're going to get these string of G&M codes here.
Okay.
So that's just verifying to the operator, hey, this matches this. That means we're calling this, and the machine knows that the data is there, so we're good to go.
Good.
So from here, I can hit start. So this is 1/4 inch mild steel,
Okay.
cutting right around 354 inches a minute.
And in the meantime, while that's cutting, I know you can kind of throw the remnants on the bed, or maybe you have one a triangular looking type of shape. All that's doing though is you're not turning anything inside the enclosure. You're merely using the XY axis to make that angular cut. Is that right?
If you're talking skewing the material.
Yeah, you
altogether.
don't skew the like the flying bridge or anything.
No,
yeah, yeah.
So the machine stays in a parallel and perpendicular position
Yeah.
to the floor. What we can do is either in that i-Cas, we can rotate the part on an angle, or we can use a G121, which is the edge detection line, which means when the program is first read, when you hit the start button, it'll do the LIS features, grab the nozzle we need, make sure it's centered before the program, and then it'll read that G121 line. And that's going to check 3 points on the sheet. So it'll check 2 in the X direction, or 2 in the Y and 1 in the X direction.
Okay.
And then it'll actually skew the program to the sheet based on the angle that it corrected. which is nice as well for if you get into automation. It helps with the automation file being read, so the head knows, the parts picking head knows where to pick those parts up from.
Oh, right. Didn't
Yeah, so
think
it's all
about that.
kind of
Yeah.
works in unison.
Yeah. Interesting. Sure.
So we did those 5 parts here of 1/4" mild steel in 1 minute and 23 seconds, start to finish.
Wow. Okay. That is very interesting what you just talked about, where that intelligence starts at the laser, because that's usually your first step, but it goes to part moving, probably down to bending if you're in line with something, probably down to joining, yeah.
Yeah, because keeping our grain direction for our bending operators could be very crucial to them
yeah.
bending and not losing parts, which would help those not so hot jobs break into the laser. That helps with those guys, and anything we can do here on the blanking side to further secondary processes, we'd like to do. So
Yeah. I mean, I'd rather have a mistake on the lasers than the laser welder, but that's only me.
that is true. It depends on how complex the part is, what kind of geometries we're working with.
Yeah.
In those cases, then sometimes it's a little easier.
That's just so funny, the connectedness of today's fabrication shop. It wasn't my dad's fabrication shop that had that,
Yeah.
so.
Yeah, the technology has come so far that essentially you can take somebody with very little experience and go through the processes and training that we offer here at Amada to learn these controls. And each one of our machines, the controls are very similar. So learning the layout from a laser will also help you with the press brake, or if you get into like our turret and a laser combination machines, it's all very user friendly. There's a lot of the same features for each day-to-day use.
Yeah, I think the only difference I've seen is maybe it's not a landscape format, it's more of a portrait format on some of the press brakes, and it's a little more free, so you can use your space the way you want to use your space.
Yeah.
But this is perfect, nestled into the cabinet there.
Yep. But given the layout of this machine, it's kind of fitting to have the screen kind of mounted inside. Some of our other lasers do have a more free-flowing monitor.
Yeah.
But this particular one is designed the way it is.
Yeah. Good. Okay. All right. Thank you.
Yep.